Thank you for coming back into the room and continue to this morning. This morning we started with things related remotely with XML, and we will continue to go deep and deep, especially with a presentation of a new implementation of XQuery 3.1, which is the new version of the standard of XQuery by Zachary Dean. And that's it.
Now everyone can hear me. Yeah. Okay. So, yeah, squirrel in Erlang. So no one knows me, I'm pretty sure, because this is the first time I've been here to Prague, XMLPrague. So little about me. I come from business intelligence, relational databases, that type background, data warehousing, so all very structured. Which then you think maybe wouldn't fit in with XQuery. But I've used XQuery in Oracle databases and used it as middleware in between. And that's where I got to really like it. Now I'm a freelancer, and I've devoted about 11 months to Squirrel, this project right here. So yeah, who knows anything about Erlang? Show hands. Cool. Use it? No? Who Googled it as they saw that it was in the list? Just one? That's not true. Two? Okay. Three? All right, so these are the things I'll go through. You see that animation was pretty cool, right? What is Erlang? I mean, what's it for? And I stole this from the Erlang website. Erlang is a programming language used to build massively scalable, soft, real-time systems with requirements on high availability. Yeah, it's used in telecom, banking, e-commerce. And its runtime has built-in support for concurrency, distribution, and fault tolerance. And that's really the whole basis of Erlang. Is this fault tolerance, is the soft real-time. It doesn't bog down when you have, well, it'll bog down, but it doesn't crash systems when you have just too much stuff running through. And scalability. I mean, the concept of one computer doing one job really isn't in the language. More than one computer can be hooked to each other and work in a cluster easily. Yeah, Erlang was made in 1986. That's when it first came out. It was open sourced in 1998. So yeah, 20 years open source. Functional language, concurrency oriented, and then using the actor model with async message passing. And there's shared nothing. Nothing shares memory. There are no static variables. There are no global variables. Things like that make it really easy to debug, easy to throw up systems in a short amount of time. And the supervision tree is kind of the basis of making applications in Erlang. The whole box on the outside being the application, you would have a tree of supervisors all linked to each other, watching each other, saying, okay, the supervisor under me, when he crashes, I restart him. And these things will also supervise, say, a server or a finite state machine, event systems like for logging. And server is the most often used. But say the server here crashes for some reason, it doesn't affect the FSM, the event, or anything else. And it'll just be restarted by its supervisor. So when you have that, you get this fault-tolerant system. So yeah, why did I make Squirrel? Well, I was in between projects, and I was looking to do something new, something that wasn't out there. I'd seen XQuery implementations, but not in Erlang. And I think OCaml is maybe one, a lot in Java, C, C++, but, and yeah, Haskell. But no Erlang. So I was like, okay, that's new. And a few beers later is actually the point. I was out drinking with friends and said, I want to do something cool, and that's kind of what came out of it. I said, I'm going to make an XQuery system. I thought I'll just start at XQuery 1.0 and see where that goes. But about a week into it, I said, no, 3.1, that's how it needs to be because it just fits in with Erlang so well. So how does XQuery work internally? Because Erlang is a functional language and so is XQuery 3.1, there's a lot of one-to-one correlations between them. So here I'll take the XQuery source document, tokenize it into everything. Here's a parentheses there as it's closing. Here's what's in between. Every word, every keyword gets tokenized in a flat list. That then goes through a parser, Bacchus-Naur format parser. I just take the grammar from XQuery. That creates a parser. There's an application in Erlang that does this for you. Add little code snippets to it, and I end up with an abstract tree that I can then run through the next few steps, that being the analysis. I'll do static analysis. Eventually, it'll have an optimization layer. It doesn't have that right now. Everything's very naive. And then it builds an abstract tree in the Erlang language, which then gets compiled. When it goes through the compiler, it can be in Beam, which is the VM for Erlang. It can be interpreted code, or it can also be native code. That means this whole system takes XQuery source code and compiles native machine code out of it. I've done a few tests on it, and that's pretty quick. It only really helps when you have high CPU usage, and XQuery does tend to have high CPU usage. So, one benefit there. So here, a really stupid, simple XQuery that probably no one would ever do or use. But just to see what it would look like when it comes out the other end, if it were in Erlang source code, it's something like this. There's a lot more to it than the simple XQuery, but that has to do with Erlang has no loops. Yeah, so I have to make them, and that means making them in recursive functions. I could explain it step for step. It's actually in the papers, and that's annotated. You can see in the I'll go through it. We have the variable tuple goes through into new in the new function. That'll be here. So I'm building my list, that 213 list, and then sending this list back in its own function with the list. I'm matching it out here. I've got a list. I'm taking out the head of the list with the tail, shooting that through the let statement, which was the next one for the head, and then running a recursive tail call for 4.1 with the rest of the list until I hit the empty list, which is the second one. The let2 part, all it does is the unary minus that was in that query there, and then makes a variable tuple with the x and y variables. That gets returned back into that for loop or for statement, which then packs that all in a list. So you have the variable tuple expanded and then returned up into the main for variable tuple 1. Variable tuple 2 then is the order by clause. That is outside of here because the order clause is pretty complex, but it uses anonymous functions. Like here I have a function that takes that variable tuple, matches it out, and says sort by the variable 2 in ascending order with empty greatest. So variable tuple 2 is now the sorted list, and then it goes through the return function, which all that does is it extracts the variable 1 out of that list, which is a lot of steps for that simple XQuery, but yeah, that's how it's done. So what can XQuery do so far? Well, it passes about 99% of the Qt3 tests, at least the ones that it runs. So it doesn't have serialization function or feature, and a few features it just doesn't have, so those are turned off and don't get run. But for the ones that do get run, it's 99% passing. A large number of the things not passing are module import and that's just based on the layout of the tests. Module import works just fine, but because it's a compiled system, once one of the previous tests has compiled something, it sees it as the same module, so just a few things to fix in the test. But almost everything is running. Now, Erlang doesn't have a typing system. That had to be implemented. A lot of other stuff didn't exist. Collations don't exist in Erlang. That had to be implemented. So I have an internal implementation of Unicode collation algorithm 10. Also, regex had to be completely rewritten, a bunch of things. But XQuery is vanilla. There's no third-party anything in it currently. What can't it do? We've got the schema-aware feature and type data along with that. That was just based on time. Didn't have time to get to it, not yet. Anyways, static typing, that's probably like a half-day project just to get it working. I just left it out for now. Serialization, that's another thing. Getting that up and running in here, I plan on changing the entire internal string structure, so until I get that done, then after that I'll do serialization. Update facility, didn't do, may do later, or at least the copy statement, the copy return, that's easy enough, but there's no underlying database attached to it, so until I know when I'm updating, why implement it? And full text, that's very far in the future. So what's next? Plan on implementing all those optional features. Parallelizing the queries is something I also want to do. Currently, it's not done that way. It's all done in one process from start to finish. It doesn't split. There are no parallel maps, parallel anything. That I'd like to change by, in the static phase, finding out what's expensive. Is there a collation sort someplace down there that's going to cost a lot? And then finding a good place up in a flower statement to split it, where it can be done in parallel and actually get use of all CPUs on a system. Then you have bindings to external sources. That'll be important for people wanting to use it, say SQL databases or NoSQL, or other XQuery, other XML databases, whatever. I'd like to implement the XPath, XQuery stuff because of the REST-XQ and HTTP client. That'll be the easiest way to attach to a XQuery system that's up and running and living, is to have a REST API to hit the ends. And while I'm at it, then WebSockets as well, because that's actually relatively simple to implement. So this would be that supervision tree that I showed what it would be for an XQuery application. This is all in the future. It doesn't quite do this yet, but these are the next things. So you have your namespace that cuts off at some place, but that's a supervisor watching everything that's under it. So say you've got your XQueries separated out. Yeah, and just based by the namespace URI, you've got your supervisor watching a certain query and then starting servers every time it's called. Servers are really lightweight, so there's not really too much cost to them. So for every time a client hits the REST API, starts a server, says, okay, run this XQuery completely through. The supervisor above it will be watching that. If it crashes, it'll tell somebody. I think there is really where some cool stuff can happen. Using XQuery to lay out applications like this, having applications speak to each other this way. And like these client sessions, they don't have to be outside clients. They can be other applications. They could be a function from this HR thing shooting over into receive. Who knows? And that's it, actually. I've left time for questions. Oh, yeah, and that's a GitHub. go check it out if you're interested. There's my Twitter. Don't write me tweets. And if you have any ideas, I am open to ideas, use cases, things where you say, okay, wow, if it could actually do all this in parallel, then this would be a great use case. I'm all ears. I'd like to test it on that and build it on things like this.
Thank you. So, any question?
Oh, there's questions. Come on.
Yeah. Abel.
There are questions.
I find it very impressive what you've been doing, and I'm really wondering, what kind of beer do you use to get to this?
Energy beer, yeah, it's what kind of beer? German beer.
So, any real question? Or?
Oh, you don't think that's a real question?
It is. And lots of beer, lots of beer. Makes you decide to do this. But it's actually, it's not as complicated as it seemed. I mean, there was a lot of complicated issues to it, but after about 8 months of full-time working on it, I had a core of the language that functioned, that passed most of the tests, and then it was just bug fixes after that. And the whole corpus of the core is what, or the 100,000 lines of code for XQuery 3.1, which I don't know what the other systems have. They're probably pretty much bigger than that. I don't know.
Well, I didn't do XQuery, so it's not really good to compare, but I used F#, which is also a functional language, just like Erlang.
Mm.
Actually, I'm not sure how many lines of code I have, but
I had to check right before this thing. I ran it through the C lines of code thing for Erlang just to see, okay, what's it come up with? And it said 100,000.
But
Now the test suites are maybe 1 million lines of code, so that's something different. But
if you don't know anything of Erlang, can you just use your system as, I don't know, an executable or something from the command line, or how would that work?
that's why I want to get towards the REST APIs, is to hide all this away. All the internals of Erlang and knowing, having to know how it works and how to set things up. I think code that uses REST-XQ or something like that, that would all be automatically wrapped in an application. It would set up the supervisors for you. And this code can be hot swapped in other machines, but really just to be a release package that you get and say, okay, shoot this into this Erlang node or these 40 Erlang nodes, or shoot it to the one and have it replicate to all the other nodes. Just to hide all that away from the user, though, with the simple scripting thing, maybe command line stuff, because I imagine that no one here really wants to learn Erlang, or if they do, then it should work right away.
Having to write your own regex and collations and things like that sounds pretty impressive within your within your time budget. What about the XML infrastructure? Do you get an XML parser and tree model and stuff like that, or did you do that yourself as well?
No, there is a built-in XML parser in Erlang, XMLPrague. It works. It works. It works on small documents really well. Large documents, let's say 100 megabyte XML, it'll take you a good 25, 30 seconds to parse it, which is kind of unacceptable. So that's something I would like to go back to and completely switch out, as time permits.
So can you try and summarize for us, what are the benefits to the end user of the fact that you used Erlang to write this?
Well, it'll be the, well, it's hard to say now because it's just passing the tests and then on a single machine. But when it does get a little further and I do implement these other things, REST-XQ, things like that, and also clustering machines together, I think that's where the benefit will come from. If you have a system that takes 30,000 XMLs a second, takes them in, it'll do just fine with that. that'll be okay. It won't crash, it's not going to bog down. I think that's where the benefit will be, is with small XMLs and really high throughput rates. And then putting them where they go with XQuery, doing everything with XQuery there, aggregating data, shooting out something on the other end with WebSockets, something like that. WebSockets that also have 100,000 users at the same time out in the World Wide Web, what have you. That's where the benefit will be, and that can be done in XQuery.
Thanks.
Jim.
Thank you very much, Zach. I think you've come to the right place. There's probably 4 or 5 XQuery implementers in the room, and that probably hasn't happened anywhere. So you're in the right place. Also, there's the best beer in the world, so you can charge up at the Monk's place tonight.
That's my plan. Yeah.
What I didn't see was a low-level API in Erlang that exposes this surface area. Do you have one of them?
Very low level and only for testing. That also just needs to come with it. Actually, I'd like to see some feedback from people saying, hey, this is really what I need. I mean, I'm familiar with what BaseX have done with their APIs and their command line stuff. I'll probably go somewhat in that direction, but yeah, APIs are to come.
And the other question is do you foresee exposing any specific options to leverage Erlang, to expose some of the things that do not exist anywhere else?
Yes, exactly how to do that and how people would feel about it, I'm not sure, but if it should be in the options above, or if it should be custom options, if it should be annotations, things like that, because Erlang has, of course, restart strategies. You have these supervisors that say, okay, when one of my children dies, then restart it. You can also have ones that say, when one dies, kill them all, or when one dies, kill them all, and then kill yourself, so you go up to your supervisor. There's all this stuff that can be done in there, this fine-grained tuning on distribution and multiprocessing that really doesn't fit into XQuery. That's still up in the air, how I would do it, how it would best do. Because I'd like to have something that will work on all other processors, of course. The same XQuery file works the same way across all vendors, but when you plug it in here, it has some magic behind it. That's kind of where I'd like to go with it.
Okay. Any other question? Oh, yes.
Hi, Tom Painter. If you were going to retarget for something than Erlang, is there anything left in your implementation? Let's say that you're going to use Scala, which is also functional, has an actors framework. And
Right.
So that's the first question. The second one is, let's say you were going to retarget. What would be the core part that's agnostic, that's not Erlang and it's not Scala, it's something apart? What would that be? And have you thought about that?
No. No thoughts about it. I drank the Erlang Kool-Aid a long time ago, and yeah, it just tastes so good. But
Okay. Another question?
I mean, perhaps an Elixir. Elixir for another language. Why? Because it also runs on the Erlang VM.
Microphone.
I'm afraid I don't quite follow. Or where actually?
Microphone.
Because if you've gotten to that point, you can say, well, this is the essence of what I've done. It's not Erlang, it's not an implementation, but it's an idea that can be reused. So what is that?
It is. Actually, it's just transpiling, but onto the beam. I mean, you can transpile from any language to any other language if you have the right tools, especially into other functional languages. I mean, truly with this transpiler, you could transpile to any other code system if you knew how to write it, or any other language. So.
JavaScript.
Okay, thanks.
To JavaScript.
No, that doesn't work. That could never work in JavaScript. I'm sorry.
Disappointed.
Actually, anything that starts with a J.
Like demo jam?
It's demo ham.
Demo
right?
ham. No question? Thank you very much, Zachary. Very good presentation. Thank you. Good work.